Hi everyone, I'm Amy Stidworthy. I'm an Associate Director at CERC and Head of our Air Quality Forecasting and Data Services. So before I talk about the calibration regime and show you some data, just a few words on how data flows behind the scenes. So Jim at Scotswells is ensuring the installation of the early sensors is compliant with the PAS. So that's PAS 4023, which is the publicly available standard on installation and operation of small sensor networks, which was published at the end of 2023. The sensors are installed using Vodafone connectivity. And then each installed sensor is transmitting 1 minute measurements of NO2, PM2.5 and ozone to the Airly server. And then those raw 1 minute measurements are captured automatically by CERC, calibrated using an innovative scale separation technique developed by Cambridge University, and then averaged hourly concentration values and made available via the public API. So the website displays the hourly NO2 and PM2.5 data, which is updated every hour. And Ricardo's role is to carry out an annual independent assessment of network performance. Our calibration approach was developed by our colleagues at Cambridge University. So that's Professor Rod Jones and Dr. Lekhan Popula. And the approach hinges on the idea that with fast 1 minute measurements, it's possible to identify a slowly varying non-local signal that is approximately uniform across the network each hour. So that regional signal is represented on this schematic graph by the red dashed line in the bottom plot. And the idea is that if the non-local signal, which you can extract, is approximately uniform across the network, then of course it means each sensor in the network should see the same non-local signal. So taking this approach means that we can do a relative calibration of every sensor in the network to one or two so-called gold sensors. So these gold sensors are sensors that are co-located with reference instruments. And then once you've done that relative calibration, the second step is to do an absolute calibration of the gold sensors to the reference data. So you have these two steps of calibration. And then the final step is to merge the network-wide relative calibrations with the gold sensor absolute calibrations to give you absolute calibrations for each sensor, for all sensors across the network. So the system that we're running will update the calibrations on a weekly basis initially, using measured gold sensor and reference data from the previous month. And I mentioned that we're also measuring ozone. So the calibrated ozone measurements are just used to correct any ozone cross-sensitivity in the NO2 measurements. The reference data that we'll be using, or that we are using in the system, of course, is unratified at the time. And the reference network is generally ratified every 6 months. So we'll be recalculating the weekly calibrations at 6-month intervals using ratified reference data as it becomes available. And that will constitute the sort of ratified Breathe London network data set. Although the calibration approach that we're using only requires a small number of gold sensors, so between 1 and 3 per network, we have co-located sensors with a larger number of reference instruments in this network. We have 3 gold sensors, so there's 1 principal gold sensor, and then we have 2 backups. And then the remaining collocations we're designating silver sensors, and these will be used for assessing network performance by Ricardo as part of their annual independent assessment. So I just thought you'd like to see a graph showing the raw data. So this is a graph of all the raw data that we've collected since the beginning of March. These are the out-of-the-box 1 minute PM2.5 concentrations from all the sensors installed to date. We have data going back to the 13th of March. This is 1 minute data, so there are many more fluctuations than you'll be used to seeing in hourly or even in 15-minute data. And you can see the graph is just dominated by a few high values, but you can also see periods where the sensors all see elevated lower levels, particularly during March and April. there are periods around April the 4th, April the 12th. You can see these areas, April the 15th, where all the sensors are moving together when air pollution was elevated. So this is the data that CERC system receives from Airly. Oh, just as the colours just indicate there's a different colour for each sensor. So you can see as the network grows and more sensors are installed, you've got more colours. So obviously you can't pick out individual sensors, it's just to give you a flavour. And this is what the calibrated data looks like. So this shows all the calibrated hourly PM2.5 data to date, which is the data you'll see on the website and that you'll be able to access via API. Obviously, you can't make out individual sensors. I just wanted to give you a sense of how the data looks in hourly world and how the sensors are tracking each other nicely while still showing some local variations. So obviously, one key question we're monitoring very carefully is how the sensors compare with reference data. As I said before, we have 3 sensor collocations designated as gold sensors, but only one of these is actively currently used in the calibration process. The other 2 are kept as backup. So this is the graph for the gold sensor at Southwark Elephant and Castle site, which is the one used in the calibration process. So the grey line is showing you the raw 1-minute data. That's the data we received from Airly. The blue line is the calibrated hourly data. So that's the data you'll be able to access via the API, and which is shown on the website. And the red line is the reference monitor hourly data. So you can see that the raw out-of-the-box performance of the sensors is very good. You can see also that the calibrated data is very close to reference. Remember, this is the gold sensor that was directly calibrated with the reference monitor, so you'd be reasonable to expect that the agreement would be very good. However, this is the same graph, but for one of the spare gold sensors. So this is the one at Hackney Northwold Road reference monitor. So this sensor was calibrated using the network calibration method, so not directly calibrated against the reference monitor with which it is collocated. So this, in a sense, is giving you an assessment of how well the network calibration method is working. And you can see that the calibrated hourly values, again, track very closely the reference values. So this is the final spare gold sensor at the Heathrow Bath Road site. Note the y-axis upper limit is lower than on the previous 2 slides because there are fewer high values in the raw 1-minute data for this site. But again, this reference data was not used in the calibration. So this sensor has been calibrated using the network calibration method. But again, you can see that the calibrated hourly data, the blue line, does track the reference data quite closely. So this is my final slide and just has a similar comparison at 3 of our silver sites. So these are sensors which are collocated with reference monitors purely for validation of the network calibration. And they sort of act as backup gold sensors if we need them, but they're mostly just for sensor network calibration validation. Again, in all 3 cases, you can see that the calibrated sensor data tracks the reference data closely. So I'm hoping you can see that the results I've shown for the PM2.5 demonstrate, well, firstly, that the out-of-the-box sensor performance is very good. We're getting consistent measurements with excellent data coverage. The results also show that the automatic quality control that we're running and the calibration system is working very well compared with reference data. So that concludes my slides about the calibration method. Today, I've shown you results for PM2.5. As I said, so we're in the final stages of preparing the NO2 data for launch. So in an upcoming workshop, we should be able to show you a similar analysis for NO2.